Alright, so today we want to talk about waves. Now there are three major kind of waves in the universe. There's mechanical, there's electromagnetic, and there's matter waves. So those are the three major types of waves in the universe. Now each one of these waves have subcategories. When we talk about mechanical waves, we're actually talking about what we most associate with waves. Okay, so when we talk about guitar strings, when we talk about sound, when we talk about waves in the ocean, we're all talking about a mechanical wave, oscillating up and down, big, massive waves, okay? So inside that mechanical wave category, there's two subcategories, transverse and longitudinal, okay? Transverse is the prototype wave. It is, when we think of waves, we think of transverse waves. That guitar string. When anybody does a demonstration with waves, we're thinking transverse waves. So you're talking about motion that looks something like this. So the wave is moving in this direction, but it would look something like that. Okay? Now longitudinal waves still has motion in this direction, but when you examine a longitudinal wave, an example of a longitudinal wave is a sound wave, the motion inside that wave, so we have oscillatory motion here while the wave is traveling in this direction in a transverse wave. So in a longitudinal wave, the wave is traveling this way, but you have motion that's going back and forth along that. So it's moving this way, this way, this way, this way, this way. So if I were to examine all the longitude, it's just oscillating back and forth while the wave itself is moving in that direction. Okay? So it's a breakdown of mechanical waves. We'll talk a little bit more about transverse. Now, electromagnetic waves we've already kind of touched on. We haven't gone into too much detail about them, but I mean that's just because we've only been energy, you see. But electromagnetic waves are light, and when I say light, I don't necessarily mean visible light. It's visible light fits in the category of light. The electromagnetic radiation is more than just way up to radio waves, okay? Gamma. So that's the full spectrum of light. Now, obviously, we don't see radio waves and we don't see gamma radiation. We don't see those. So in order for it to be light, it doesn't necessarily have to be visible light. Okay? Now, radio waves, big waves. Now, if you talk about the size of that rate, that's 10 to the 4th. About it, if you took a number like 4 and you multiplied it by 10 to the 3rd, you're talking kilometers. So you got tens of kilometers. You're talking about basically tens of miles. It's a huge, huge distance. Okay, and that's a single wave, and we'll talk about that's the wavelength of that thing. That's the distance from peak to peak. That's a huge wave. Okay, well, our visible light waves are considerably smaller, going to 10 to the negative 6, smaller and smaller and smaller and smaller and smaller. Okay, very, very small waves on these. Now, gamma waves we've talked about when we talked about radiation. It's when particles are reorganizing themselves, they may emit a gamma ray. That gamma ray is 10 to the negative 14th. That's okay? I mean, it's a very, 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 very small wavelength. Okay, there's no way I could draw it 10 to the negative 14th. Okay, it's that small. I mean, you're talking on the order of what, maybe a cell? Maybe even, no, less than a cell, more than likely. Yeah, certainly more than less than a cell. You're talking on the order of like an atom or a molecule. I mean, it is tiny. Okay? But the interesting thing is because of the relationship between energy and wavelength, this is high energy. This is very, very high energy. And then relatively high energy and then very low. Incredibly small wavelengths, very high energy. Okay, so that's electromagnetic, and the last one is matter waves. Now, as I put down here, matter waves are atomic and subatomic particles, and typically when we talk about matter waves, we're concerning ourselves only with the atomic and the subatomic scale. But in the case of some of our condensates, some of our forms of matter, which are Bose-Einstein condensates and fermionic condensates, we're talking about more than an atomic particle. You could actually have a pocket of particles that behave like a matter wave. Okay? But typically, we are concerned with atomic and subatomic. Okay? So it's like rundown of waves. It's mechanical, electromagnetic, and matter. And then each one of them have their own subcategories. Okay? And now I'm going to go in a little more detail about each one of those waves.